After realizing the necessity of new types of number system and also realizing there is a gaps in between rational numbers, we studied what is meant by ordered sets. While explaining this, I showed my concerns about misleading of the Rudin's definitions, and it doesn't mean that Rudin is not aware of this or unaware of this. He knew, but he don't concentrate on the foundational build-ups. This may leads to misunderstanding of the concepts like, oh, we know what is meant by less than or greater than symbols, and we are doing, yes, we know with some kind of operators. How can we say x is less than y? We say if x minus y is less than 0 is a negative number, then 0 is also a rational number. And how can you comparing them? Because we are just defining what is meant by comparing, and then we are using the comparison to define the comparison. So these kind of philosophical things comes to brain when we think that we don't know what is meant by real numbers. And of course Rudin also knows that, and Rudin already said that, I think you know about everything about rational numbers, even rational numbers. Inside the rational numbers, we need concepts like ordered set. Now also we are going to deal uh, further more different types of concepts which are again uh, not in my point of or my type of explanation in the Rudin book, and I want to give my explanations and as well as the Rudin explanation. And Rudin's main concentration in this chapter to show that there exists a ordered field known as a real number system which has the least upper bound property. That is his main concentration in this chapter. And throughout this book he have lot of other bigger things to deal with, like convergence, continuity, differentiation and integration. So he don't think, or he don't have an intention to explain more about the foundational things. So this is what happened in the book. And I feel if somebody reading it, they should know what is the differences are there, or what are the uh, concepts which may mislead, because these are the things which misleaded my journey in this book. Also, I read this book, or especially the first chapter, for 3 or 4 times, and each time I getting new questions. So I don't want anybody to confuse in the first step, so that they can think very much higher. So in this video going to study about bounded above. What is meant by bounded above? This definition is that, or this concept is definitely belongs to a set. So how can we say a set is bounded above, or how can we say a set is bounded below? Again, these words bounded above and below, these are all the things which we already knew, or which we already using in our day-to-day life, like this, which is greater, which is lesser. And Rudin also don't want to go away from the notion of lesser than or greater than symbol, or lesser than or greater than feeling. So he stick with the symbols greater than or lesser than. So suppose S is an ordered set and E is a subset of S. So we got an ordered set. Here again, one should see the video number 3. What is meant by order? Order is here our less than symbol, and don't fall for the word less than. Just go with the notion like some R is there, like x less than y. Instead of writing that, you can write x r y. I mean, x is related to y with all the properties satisfied with the R. We can say S is ordered set. So suppose S is an ordered set, E is less than, E is a subset of S. In fact, You can take proper subset also, there is no bigger issue. If there exists an element in the, yes, say beta, so if there exists a beta belongs to S such that, see here, x is less than or equals to beta, that doesn't mean x, the value of the x is less than beta. This is my way of explanation, but in order to understand it, you can take the help of the lesser than, and you may take that S as the rational number set. So E is a subset of rational number set. So if there exists an rational number such that x is less than or equals to beta for every x belongs to E. This is an example with the uh, notion of lesser than. So but to generalize thing, you can take, you can think like x is related to b, sorry, beta, if there exists a beta in S such that x, every element in E, okay, so every element in E are related to beta, or every element, one of the element or every element or beta itself. And in order to avoid what is meant by equality and all those things, you can take distinct elements. Then since beta and x are distinct, the only possibility should be, if they are not distinct, if there exists an element in the E which is beta itself, because S is a superset, right? So beta can be inside E or maybe outside E also. So you can avoid the philosophical feeling or philosophical notion of equality. So if there exists a beta belongs to S such that x is less than or equal to, that means x is related to beta or x may be beta for every x belongs to E. Then we say E is bounded above. Why the word above? Of course, Rudin is going to deal with the rational numbers, real numbers, where he going to bring the order as the less than order. That means what we know what is meant by less than, right? So he is going to bring that order with the help of the cuts in the appendix of this chapter. So he will explain what is meant by cut, and then he will explain how can we define some number is less than other number without taking the help of the subtraction. Because if you are doing subtraction, then zero is also on one of the element, and you assume that all negative numbers are less than zero. We don't know whether all negative numbers are less than zero. Of course we know, but we don't have a, a philosophical or a foundational background whether zero is greater than all the negative numbers or not. So to avoid that, he took the help of the cuts definition, uh, and in order to understand this much, this little more, um, it is better to study some of the works of the dedicants, and I'm doing that also. So in that, he represents cuts as a subset, and if there are two subsets, okay, well, we can map every real numbers to a cut. uh, I will explain what is meant by cut and how to define the order in the real number set, all those things, because the main intention of this chapter number 1 in the Rudin book is that itself. I'm just giving you some glimpse of the future. So he explained that if two sets are, if two numbers are less than or equal, less than, for example, x, if x is less than y, then there must be two cuts belongs to the x and y such that the cut belongs to x is a proper subset of the cut belongs to beta. So then we can do this. So this is a very interesting thing, and this is the core of this chapter, and this is not said by me also. I mean, this is the core of the subject. Rudin said that this is my intention, or this is the core of this chapter. So that's why I understood now that that is why he not took examples of the real numbers while giving the definitions of the bounded, bounded above, bounded below, supremum, infimum. With all, in all those explanations, he never used the example of the real numbers. And why he never used the example of the real numbers? Because he not defined the real numbers. Of course, in this book also, he's not going to define real numbers, but he not yet defined the structure of the real numbers also, or not explain the structure of the real numbers. Therefore, he not use the lesser than symbol. Similarly, why he used the less than? Because he don't want to discuss about the philosophical or foundational backgrounds of uh, orderness and all those things. So he not explained this much. Uh, but I feel that he should have explained this much. You remember, right? What is the negation of this order? We talked this in the video number 3. It is this, it is represented by this symbol greater than or equals to, and I'm not going to talk about once again what is the intention of the Rudin, all those things. You just take it in whichever form you like to understand. Suppose S is an ordered set and E is a subset of S. If there exists an element, if there exists a element, a beta in the set S, such that my way of interpretation of this is such that X is not related to any of the X is not related to beta. That means X is greater than or equals to beta for every X belongs to E. You can take that greater than symbol in whichever form you like to understand. Okay, then we say E is bounded below and beta is called lower bound of E. In order to understand with the help of greater than or lesser than symbol, you just take instead of S, Q, rational number set, and E is a subset of rational number set. And if there exists a rational number such that every element of the X are greater than or equals to that, every element of E are greater than or equals to our beta, then we can say beta is the lower bound of E, and B sorry E is bounded below. Why? It is have some numbers, which it has some rational numbers which are lesser than every element of E. So it's like lesser comes lower, and higher comes upper. It's like some built-in kind of explanation. We know why those people give below or above. It is like a natural instinct. If it is less than, we will say below. If it is greater than, we will say upper, or up, bounded above, bounded below. So don't worry about those things.